Okay, we're going to find the zeros of the polynomial shown there. This is all the information that we're given. We can see from looking at the degree of the largest exponent that this is a third degree polynomial. So we're looking for 3 zeros. They may not be unique. There may be repeated roots, so roots that have multiplicity greater than 1. Since this is all the information that we're given, we're going to begin by graphing the polynomial. So we graph it, x cubed. Whoops. All right, so there we go. And we can graph it. Okay, we think that might, well, there's a 0. Is that at -3? So we could do the zeros, but let's try the table. So let's go to table, and we'll just, our zeros were smaller, so we'll go down. Okay, right here, see this is negative and this is positive. So somewhere between -3.5 and 3 we have a 0. So that 0 is not an integer. Oh, look, here we have -1 and 0. So x equals -1 is a 0. If I flip through here, okay, and then here I go from negative to positive. So somewhere between 1 and 1.5, there's a third 0. So 2 of them are not integers and 1 of them is. So we have an integer root at x equals -1. So this is how we're going to use it. One of our zeros is at x equals -1, which means that, so I can think of this as an equation. I add 1 to both sides, and so I get x plus 1 equals 0. This is a factor of the polynomial. So what I'm going to do is take this factor and divide it into my polynomial. Okay, so x goes into x cubed, x squared times. So I do x squared times x plus 1, and that goes right there. So that's in the way. Not quite what I wanted. Okay. I'm going to do it over here. Normally I do this right there, but I haven't given myself a reference. So x squared times x plus 1. So that's x cubed plus x squared. Then remember, just like in long division of numbers, I take that product and subtract it from the original. So the x cubed cancel, and I get 3 squared minus 1 squared, which, or 3x squared minus x squared, which is 2x squared. Bring down my 2x, and so x is going to go into x squared 2x times. So over here 2x, and then x plus 1. And that product, that result goes over here. So 2x times x is 2x squared. And then I subtract, so that goes away, and 2x minus 2x is minus 4x. And then the minus 4 comes down. So x is going to go into minus 4x minus 4 times. And then that result goes right here. So minus 4x minus 4 and subtract gives me remainder 0. So what that means is that over here, this polynomial factors into x plus 1 times x squared plus 2x plus 4. Oops. And we find the zeros by taking each factor and setting it equal to 0. So this one has already been done. I got x plus 1 equals 0, which means x equals minus 1. So let's look at this one here. X squared plus 2x plus 4 equals 0. This doesn't factor, so I'm going to have to use the quadratic formula. So remember, first I find the determinant. So that is b squared minus 4ac. So that's 2 squared minus 4 times 4 times 1. And so I get something wrong. Oh, I can't copy. That's a minus. I was about to say, I'm going to get a negative, about to get complex roots, but I saw 3 roots, so I knew I was screwing up somewhere. Okay, so we get 4 plus 16 is 20. So my quadratic formula is minus b, so that's minus 2 plus or minus the square root of this all over 2a. Okay, now 20 can factor into 4 and 5, and since it's multiplication, we can break that root up. And so the square root of 4 is 2, so minus 2 plus or minus 2 square root of 5. And now I can, on top, factor out a 2. And those cancel. So I end up with the zeros minus 1 plus the square root of 5 and minus 1 minus the square root of 5. And there's my 3 zeros. I can check this by going back to my calculator. I'm going to go to the graph. I'm going to trace. Where's trace? There we go. And I'm going to type in minus 1 plus the square root of 5, and I get 0. So that is, in fact, a 0. So that one was correct. Now let's look at minus 1 minus the square root of 5. And that is 0 as well. So we found the 3 zeros for a third degree polynomial. Okay, now we want to find the zeros of this third degree polynomial. And this is all we're given. We see that it's a third degree, so we'll have at most 3 unique zeros, and we could have fewer if we have repeats. Okay, so we begin again by graphing. So 42 x cubed minus 31x squared minus 10x. Whoops. It will not like that. Plus 8. Okay, so we graph. All right, so something's going on there. Let's start by going to the window, and we don't need that much x-axis, so let's go from -2 to 2 and see what happens. All right, so there is a 0, and then this may be 1, 0, or 2. It's hard to tell from this level. So what we're going to do is we're going to go back in and we're going to make the y-min much smaller, or the y-axis much smaller. So we're concerned, or we're interested in when y is equal to 0, so we don't need to go from -10 to 10. Let's just go from -1 to 1. Okay, and so we see a little bit of this graph below the y-axis, so that means that this is 2 zeros very close together. Okay, here's -1, so 1 0 occurs between -1 and 0, and 2 zeros occur between 0 and 1. So none of these zeros are integers. What we're going to do to find the first 0 is we're going to use the intersect, or the 0. So left bound, okay, 0 is fine. Now we have to be careful. Okay, we're starting to come down. All right, so the right bound, see how this is negative and over here it was positive? So my 0 occurs somewhere between there and there. So this is going to be my right bound. So remember, we have to bracket the 0. And we get 0.5714287. That could be irrational. Let's look at some of the other zeros. I know that I picked one that was a nice fraction, so since I know that, I'm going to look for a different one. My left bound, okay, I'm going to look for this one right here. So I'm going to start negative and go positive. So that one doesn't have a very big one. Okay, now that's a fraction I recognize. That is 2/3. Okay? So this 1 0 is 2/3. So we're going to use that and go back. So I know that x equals 2/3. So if I so this is an equation. If I multiply both sides by 3, I'm going to cancel the 3 on this side, and I get 3x equals 2, and subtract 2 from both sides, and I get 3x minus 2 equals 0. This is a factor of the polynomial. So what I'm going to do is take this factor and divide it into the polynomial that I'm given. 42x cubed minus 31x squared minus 10x plus 8. Okay, and now I'm going to divide this in here. So 3x will go into 42x cubed. Well, 3 goes into 42 14 times, and then x goes into x cubed, x squared times. So 14x squared times 3x minus 2 gives me 42x cubed minus 28x squared. And remember to subtract. So that crosses off, and I get minus 31 plus 28, which is minus 3. The minus 10 drops down, or the minus 10x drops down. So 3x goes into minus 3x squared minus 3x times. So minus 3x times 3x minus 2 minus, oh, whoops. No, it doesn't. It goes in minus x times. Okay, now I get minus 3x plus 2x okay, so those cancel, and I get 10, or minus 10 minus 2 is minus 12. Minus 12x bring down the 8. So 3x goes into minus 12x minus 4 times. There's minus 12 plus 8. And there's my remainder of 0. Okay, so what that means is that this polynomial can be factored into 3x minus 2 times, whoops, 14x squared minus x minus 4. Now I can use the quadratic formula on this. So I'm going to, so I can take each factor and set it equal to 0. That's already been done here. So now I need to do this, set this equal to 0. Now let's see. 14 factors into 1. Oh, well, this could factor. This probably does factor, but we use the quadratic formula. So we have A, B, C. So I'm going to look first for b squared minus 4ac. I should get a real number, or a positive number, because I had 3 zeros on the other page. So b squared is 1 minus 4 times 14 times minus 4. So that minus combines with that minus to give us a plus. So this is 1 plus 4 times 14 times 4. So plus 224. So that's 225. So minus b plus or minus the square root of b squared minus 4ac, which is 225, all over 2 times a. Okay, well, the square root of just 225 have a perfect square. Square root 225 is 15. So this is 1 plus or minus this 15, because that's the square root of 225, all over 28. For 2 times 14 is 28. So I get 1 plus 15 over 28, and 1 minus 15 over 28. So 1 plus 15 is 16. And I'm going to use my calculator here. 16 divided by 28 as a fraction is 4/7. And then This one, 1 minus 15 is minus 14 over 28 equals minus 1/2. So if I'd found the 0 on the other side, I would have gotten minus 1/2. It might have been a little bit easier, but it doesn't matter which one, just start with one you can find. So my zeros are 4/7 and minus 1/2. And then the last thing we're going to do is go back to our calculator and verify that those are indeed the correct zeros. So trace minus 1/2. There's x equals minus 1/2, which has a y of 0, so that is a 0. That's correct. Then the other one we had was 4/7. So I type in 4/7, and there is my other 0, and that's that 0.57142857 that I wasn't sure if it was irrational or not, but it is rational. When you have a denominator of 7, it has very weird thing. But we can see it start to repeat right here. 571428, and then 57 ... So it is rational. It's just hard to tell when this is all that you have whether or not the fraction is going to repeat or not repeat, or even terminate. I mean, that could have been it. I couldn't tell. All right, so those are the zeros, and those are the polynomials we were going to look for zeros for.